Hi everyone. So this is our lesson on conversions between exponential expressions and log expressions. So I'm going to start with this warm-up over here just to kind of give you some review. So if you think back to last unit when we were talking about exponentials, we have 2 to the something power equals 8. So 2 to the third power would equal 8. I'm going to skip B. And if we look at 2 to the something power equals 16, well, that would be 4. All right, notice that in A, in B, and in C, our base of our exponent is 2, it's 2, and it's 2. So in A, we're saying 2 to the something power is 8, and then in C, we're saying 2 to the something power is 16. So we've raised 2 to the third, we've raised 2 to the fourth. It would make sense that logically then 2 to the something would be 10, and that it would have to be an x value between 3 and 4. So between 3 and 4. So x is some value that is a decimal answer, not a whole number. And in this unit, we're actually going to talk about how we can answer that question, so how we can actually solve that exponential equation. We're not specifically going to get at that today, but we are going to get at that in this unit, but that's why we're actually doing all this stuff. Okay? So there's a lot of objectives that we're going to talk about today. So I wrote them all out for you guys. We're going to do some rewriting. So we're going to take exponentials and we're going to rewrite them as logarithms. We're going to rewrite logarithms as exponentials, so being able to go back and forth between exponentials and logarithms. We're going to evaluate logarithms, which means that we're going to get a value. So saying like 2 to the third power, that's an evaluation to say that that's 8. We're going to evaluate when we are given logs. We're going to simplify logarithmic expressions, and we're going to solve very basic equations with logarithms. Okay? Alright, so logarithms are inverses of exponential functions. We've kind of been talking about that back and forth, how if you had x squared, its inverse would be the square root of x because they undo each other. Logarithms are inverses of exponentials. So if you have an exponential function, a logarithm would undo it, or vice versa, an exponential would undo a logarithm. Okay, so key idea here is that a logarithm is an exponent, which is why we use them with exponential expressions. Okay. The common logarithm has a base 10 and is usually written as follows. So notice that 10 to the third equals 1,000. That's the same thing as saying log of 1,000 equals 3. The reason is because this is a 10 right here, so we'd actually read that as log base 10 of 1,000 equals 3. And notice then if I put 10 to the third power, that equals 1,000, and that's the exact same equation that this was. So we'll talk about how you can rewrite that. Okay? If we write the square root of x, it is implied that there's a 2 here. Same way here, if we say log base 2, the base is 2. However, if we just say log, it's implied that the base is a 10. Same idea as this. Okay? Using your calculator, we're going to evaluate each of the following. This is the only place that we're actually going to use our calculator, but I did want to get used to where these buttons are on our calculator. So if you take your calculator and type in log, the log button is next to the 7 button. So log of 27, and I get, rounding to 2 decimal places, that this is about, what was that number? 1.43. Okay. In the next one, I actually want you to cross off this log, and I want you to write LN, which stands for natural log. Natural log and log, the nice thing about them is they hold the same properties, but they do give you different values. So in the calculator, natural log is below log, so you want it to say LN, and then you can either put 3 divided by 4 or 0.75, and notice that you get negative 0.29. So about negative 0.29. Okay, and then the next one, we have log of negative 6. So log of negative 6, notice, gives you a non-real answer, and that will happen every time that you try to take the log of a negative. So can you just write here, cannot take log of negative number. Okay, you can put your calculators away now. Okay, so let's talk about how to rewrite between forms. So you're first given an exponential form and asked to rewrite it as a logarithmic form or a log form. And then I'm going to flip it on you and I'm going to give you the logarithmic form and ask you to write it as an exponential form. So we're going to go back and forth in writing these. And in doing so, it actually allows us to evaluate and solve without a calculator, which is nice. Okay. So the first one I wrote out for you, notice that it says a to the y power equals x. So that's an exponential. It can be rewritten or is the same thing as log base 8. I actually want you to write this out. So write log base a of x equals y. So if you were to read this, you would say log base a of x is y. Okay? And the way that that's obtained, I always look at it this way, and I always add a log to this. And then you can see that if I circle this, notice all three of those things are in the same level, the log, the a, and the x, which is why they're grouped together as log base a of x, and then it's always equal to your exponent. Okay? So if I do that in the next problem, I throw a log here, and then I circle these things, leaving out the exponent. That means that 3 to the 4th power equals 81 is the same thing as saying log base 3 of 81 is equal to the exponent of 4. Okay? So let's try it again. Color here. Alright, so if I throw a log in front of here, circle all of this, leaving out my exponent, 2 to the 5th equals x is the same as log base 2 of x, which equals the exponent of 5. Okay? And then last one. The next one I would say log base x of 12 is equal to the exponent of 6. Okay? Okay, so now let's flip that. Let's say that you're given the log form and you want to change it to the exponential form. Okay? So I always remember this as a way that my teacher always explained it to me when I was in high school. And he always said it's like George of the Jungle. So if you know anything about George of the Jungle, think about when George is swinging from the trees, he always starts on the ground and he has to work his way up to the trees and then back down to the trees. So here's what that means. He always starts on the ground. Notice that this A is the furthest down. It's on the ground, and he has to swing up to the trees, and then he has to swing back down to the ground. Okay? So notice that that's a to the y power equals x. So if I apply that here, I would say, okay, George has to start on the ground, so it's 6. He has to swing up to the trees, which is why I'm putting that up above, making that an exponent. And then he has to swing back down to the ground, which is why I'm no longer at an exponent. I'm back on the ground at 24. Okay? So let's try it again. So George starts on the ground. He swings up. So he starts on the ground. He goes up. And then he comes back down to the ground. So equals 81. And notice because of how I rewrote this now, I can actually say, well, x to the 4th power equals 81. Well, that's 3. So 3 to the 4th power equals 81. I couldn't solve this before because without a calculator, how would I do that? And even with a calculator, I wouldn't know what to put in my calculator. But by rewriting it, I now can actually evaluate this. Okay? So the next one, rewriting again, we're going to say he's on the ground, he swings up to the trees, and then he comes back down, and he equals x plus 2. And now I could solve this too if I wanted to. I'd evaluate 2 to the 5th, I'd subtract 2 over, and I could figure out what x is. Okay? Alright, so I look to the back side. Alright, so I'm going to evaluate all of these without a calculator, and I'm going to stress to you that I'm evaluating. Okay, evaluate means you're getting an answer. It doesn't mean that you're solving. Solving is undoing something. Evaluating is an answer. If I told you 3 squared, that's an evaluation. That's 9. Okay, that's what I'm doing here. So, I'm going to use those rules that I just had. So all of these are logs. I'm going to rewrite them as exponents. So I'm going to say, okay, well, George is down he's on the ground. He's got to swing up, but there's nothing there. So instead of writing, I have a couple choices here. I can write a variable if I want to. I could write a question mark if I wanted to. I'm going to write a box because that's what I'm looking for. So I'm saying 4 to the something power, and then he has to swing back down, is equal to 64. Okay? You can use an x, and typically we do. However, this is why I'm not going to. If you look down here at numbers 9 through 12, notice that all of those already have x's because I'm simplifying in these. If I use an x when I already have an x, I can't do that. I'd have to use a different variable, and now it gets confusing because I have multiple variables. So typically I actually want to stay away from x when I evaluate. Okay? So back to this problem. 4 to the something power equals 64. Well, that would be 3. So by rewriting the log using my rewriting rules, I just figured out that log base 4 of 64 is the same thing as 3. Okay? Notice that I didn't say x equals because it's not an equation. All right, next one. Log base 7 of 49. So I would rewrite this and say, okay, he's on the ground. He swings up to something that we don't know. He swings back down to the ground, and that's equal to 49. So 7 to the what power is 49? 2. So log base 7 of 49 is the same thing as 2. Okay? All right, next one. So George is on the ground. He swings up. So 5 to the something power swings back down equals 0.2. All right, so here's where we get to this, and we're probably thinking, what do I have to do without a calculator? Well, here's what we do. We rewrite it. 5 to the something power. I can rewrite 0.2 as 1/5. And I can see that these kind of look the same because they both have a 5. So then here's what I'd want to do next. I'd want to say, well, 1/5, if you think about it, 5 to the first power is 5. But if I make it a negative, 5 to the negative first power means you take 5 and you do the reciprocal, which gives you 1/5. So 1/5 is the same thing as 5 to the negative first power. Now that I have the same bases, that means their exponents have to be equal to one another. So that means that the something that I don't know has to be -1. So I just figured out that log base 5 of 0.2 is -1. All right? All right, so next one. I'm going to say that 1/5, this whole thing to the something power is equal to 125. Okay, I'm going to do the same thing I did in the last one, and I'm going to rewrite this. Well, 1/5 is the same thing as 5 to the negative first, and then I'm raising that whole thing to the something power. So 1/5 is the same as this. Still need to raise it to the something power. 125 I can rewrite as well. I know that that's 5 to the third power. Okay, so now look at what I have. If I have 5 to the negative first raised to something, that's I'm multiplying my exponents, so that's -1 times something equals 5 to the third power. Notice I have the same thing that I did in the last problem. I have the same base. Well, if the bases are the same, then their exponents must be the same. So now I can say that -1 times something equals 3. Well, since this is multiplication, I would divide by -1. 3 divided by -1 is -3. And that means that log base of 1/5 of 125 is -3. Okay, next one. All right, next one, I would say 36 to the something power equals 6. I can rewrite 36 as 6 squared and then times that box because it's to the second raised to another power equals 6, and I can put that to the first power. Notice that their bases are the same, so that means that, that means that 2 times something equals 1. So to get that something by itself, I would divide by 2, meaning that my answer is 1/2. All right, let's try again. This one is saying 22 to the something power equals 1. All right, so rewriting this isn't really an option because 22, I really can't rewrite it like I did in the last one and said 6 squared. But if I remember my exponent rules, if I raise anything to the 0 power, it gives me 1. So my answer is 0. Okay. Next one, I would say 9 to the something power equals 1/3. Well, 9 is the same thing as 3 squared times something equals 1/3 is the same thing as 3 to the first, but I make it negative so it's the reciprocal. Notice my bases are the same. Since my bases are the same, I'm having 2 times something equals -1. Divide by 2 so I get that box by itself, and I get -1/2. Okay, again, notice that I'm not writing x equals because these aren't equations, it's just evaluating. Alright, next one. I have 4 to the something power equals 1/2. And I can rewrite this. So I can say 4 is the same thing as 2 squared times something equals 2 to the negative first power. Notice my bases are the same. So that must mean that 2 times something has to equal negative 1. Just like the last problem, I divide by 2. I get negative 1/2 is my answer. Okay, and you'll have a bunch of those problems in your homework to practice evaluating. So basically the concept or the routine is to get the bases to be the same. If you get the bases to be the same, then the exponents have to be equal, and then it becomes a pretty easy solving problem. Okay? And the next one we are simplifying. Simplifying means that we are no longer getting a value, not like 12 or 15, but we typically, when we say simplify, means that we're actually going to get an expression as an answer. Okay, evaluating, it means that we're getting a number. Simplifying means that we're typically getting an expression, so we're getting a variable. Okay, so if I do the same thing that I did before, I would say 5 to the something power equals 25 to the x power. Leave this, but I can rewrite 25 as 5 squared times x. And now I can see that this box is equal to 2x since they have the same bases. So the simplified expression that I get, or my answer, is 2x, since I got that box by itself. So I don't know what x is. I can't say it's 12 or anything like that, but I can say that log base 5 of 25 to the x power is the same thing as 2x. All right, next one. I have 7 to the something power equals 7 to the negative 3x. The nice thing about this one is the bases are the same, so right away I know that that unknown is negative 3x. Nothing to solve because it's by itself, so there's the simplified expression. Alright, next one. 2 to the something power equals 64 to the x power. So I leave 2 to the something equals, and 64 is the same thing as 2 to the 6 power times x. So then I get the same basis, so I know that that something is equal to 6x, which is my simplified expression. Okay? Alright, next one. Alright, this one's kind of weird because of the fact that the log is in the exponent, which means actually I'm going to rewrite this using a log. So watch what happens. I can say log, and if I use my rules from the first page, that means that I'm going to have log base 8, and then I look to the other side, but there's nothing there, so I would say log base 8, because remember we did this before it was circled, and we said that left out the exponent. So I would say log base 8 of something that I don't know is equal to that entire exponent, which is log base 8 of x. And look at how I rewrote this. They both have log base 8, therefore these two things must be the same thing. So that unknown is x. Okay? Alright, so we do all this so that we can kind of build to the fact that not only can we evaluate and simplify, but we can actually solve an equation in the very basic sense, because we're going to get more in depth with this. Alright, so using those rules that I just talked about, let's rewrite. Now notice that we actually have an equation, so we're actually going to get an answer of like x is 12, x is 8, something like that. Okay? So, George is on the ground, he swings up to the trees, he swings back to the ground. So 5 to the third power equals x plus 1. 5 to the third is 125 equals x plus 1. Subtract 1, you get that x is 124. Alright? Okay, next one. Same idea. George is on the ground, he swings up to the trees, so x squared equals 64. In order to get x by itself, I square root. When I square root, I get two answers, so plus or minus 8. However, we talked about this on the front page, you cannot take the log of a negative. You also cannot have a base that is negative. So I want you to write here that x equals 8 is my only solution. Put an asterisk next to here, and we're going to say bases cannot be negative. So even though we got a plus or minus, we could not have a negative base. Okay? All right, there is one problem that I want to show you on the homework that's going to come up that's very similar to that problem. So on the very bottom, if you look at number 30 here, if I use the same rules that I just talked about, so George is on the ground, he swings up, we have to be very careful on how we write this. So this is 3x squared equals 36. So that's our tendency of how to write that. And when we say it, it's right, but when we write it, we have to be very specific that we are squaring the entire expression. So it's not 3x squared, it's 3x, that whole expression squared, because I need to distribute that squared to both of those numbers, making this 3 squared, which is 9, x squared equals 36. And then I can solve the problem. Okay, but 9x squared equals 36, not 3x squared. All right, I'm going to email you guys the notes and the homework, so if you were gone, you have them. So please be ready for tomorrow. We're going to talk. We're going to talk tomorrow, and we're going to go through all these rules again before we start graphing them the next couple of days. All right, I'll see you guys tomorrow.